Hello, everyone. My name is Elham Tabassi. I'm Chief of Staff at Information Technology Laboratory at the National Institute of Standards and Technology, which is part of the U.S. Department of Commerce. I'm happy to be here to talk to you about the NIST Trustworthy AI program. A couple of words about what is NIST and what we do. Home to 5 Nobel Prize winners, NIST has an incredibly broad portfolio of responsibilities. As America's laboratory for advancing innovation, we do everything from building the world's best atomic clocks to developing standards for robots in manufacturing to help firefighters predict the behavior of wildfires. NIST has a long-standing reputation for cultivating trust in technology by participating in the development of standards and metrics that strengthen measurement science and make technology more secure, usable, interoperable, and reliable. This work is critical in the AI space to ensure public trust of rapidly evolving technologies. As I mentioned, NIST has a very broad portfolio of research, and AI is being used for scientific discovery across many different projects at NIST. But for the purpose of my talk today, I'm going to focus on the work that we are doing to advance trustworthy and responsible AI at NIST. So what we're doing, so as we all agree on the potential of the AI and how it's rapidly transforming our world, still we know that the development and use of new AI-based technologies are not without technical challenges and societal risks. And there's these two end of spectrum and a lot of other opinion in between. The optimistic views is that the AI will change our lives for better in ways that we don't know yet. But there is also pessimistic view that it has negative impact on job. It can exacerbate the trend of the rising inequalities, and some even think that AI can be a threat to humanity. And as we all know, the truth lies somewhere in between. While AI offers many positive benefits, it can lead to significant unintended consequences for individuals, organizations, and society. So it's really important to understand AI risks and their drivers. And one challenge is that despite the consensus that there are several types of risks associated with AI, there has yet to be a concerted effort around establishing a taxonomy of AI risks. A taxonomy that describes the various types of risk and how they can be managed is necessary for future efforts to test AI and eventually build human trust and confidence in AI. In my talk, I'm going to go between risk and trust because we believe these are the two sides of the same coin. You improve and increase trust and confidence by managing and diminishing risk and vice versa. And we have been engaging public and private sector in discussions about trust and trustworthiness, what they mean, and trying to unpacking these concepts. What are the associated measurement methods, standards, and tools for building and testing and designing and buying and evaluating trustworthy and responsible AI. And you might know that right now we have a request for information for development of AI risk management out. The request for information is open until September 15th, and I'll be talking a little bit about that. So what we need to do, to advance trustworthy and responsible AI, we need to know the technical requirements or building blocks for AI. We basically need to know what constitutes trust, right? We welcome the global discussions around trustworthy AI, and there are many really good documents out. Examples of that are the OECD AI principles and several other national policies, including some documents in the US. And the good news is that these documents are all there are very similarities, and they're all human-centered and promote the democratic values. The challenge is that these principles are aspirational, and the opportunity for us, the tech community, is to translate these aspirational principles to technical requirements that are clear, implementable, and testable. So what we need to do is basically answer the question of what constitutes trust. And speaking the language of risk, what's a taxonomy of risk? That's the lowest bottom of this pyramid that I have here, that we need to identify building blocks or technical requirements for trustworthy AI. The technical requirements or the core building blocks that we have come up so far in close collaboration and consultation with community are components such as accuracy, reliability, safety, security or resilience, robustness, explainability or interpretability, privacy, and mitigation of bias. Other factors such as fairness, accountability, and transparency should be considered, especially during deployment. So when we have that, when we come up with these building blocks, in other words, when we know what it is to measure, then we need to come up with a clear and common set of vocabulary to express each of them. We want to bring a whole community on a shared understanding, for example, what we mean by explainability. It's often that we use the same term meaning different things, or using different terms to talk about the same thing. So we at NIST think that coming up with a set of terminology and taxonomy is an important first step to be able to have discussions about risk management framework, or basically about any discussions, but in this case, risk management framework. So these two steps, identifying the building blocks and developing terminology and taxonomy for each of those building blocks, answer the question of what to measure. Once we know what it is that we want to measure, we can work towards development of metrics and testbed for benchmarking and performance evaluation on each of the aspects of technical requirements for trustworthy AI. That's the third layer from the bottom on this pyramid, and that answered the question of how to measure. We think that developing such a solid scientific foundation about what to measure and how to measure is essential for development of clear, technically sound, voluntary, consensus-based standards that are globally relevant and have developed in an open and transparent manner. Once we have all of these pieces in place, which is scientific foundation and technically sound standards of what constitute trustworthy or risk, how to measure them, what data to use to test, benchmarks, performance and conformance assessment standards, etc. in place, we have the right ingredients for development of our risk management approaches, where developers or users for each application decide the appropriate level for each of the aspects of trustworthy AI and manages the interactions among those. For example, the current techniques improving explainability may reduce accuracy of the machine learning technique. The emphasis on the point here is that there is no one-size-fits-all approach, and the same technology for different use cases will have and exhibit different level of risk for the different aspects of risk that we talk about. An example of that is, for example, if you're using face recognition for law enforcement applications versus using face recognition for unlocking or cell phone or access control to, for example, places like a gym or some place that it's not very high security. Knowing the taxonomy of risk or core building of the trustworthy AI, having a shared understanding or terminology and taxonomy, having a good basis for measurement science and metrics for measuring each of them, it gives us the right ingredients for development of a risk management, and all this would be good foundations for evidence-based policy making. So let's talk about the core building blocks of trustworthy AI, and I talk about them very briefly in my previous slide. So what can or should be measured to give credibility and confidence to machine learning algorithm? And what I have laid out for you is those building blocks or technical requirements that, as I said, we came up in consultation with community, but again, as I said, we have a request for information out that we really want to hear from the community that, are these the right set? And do we need any additional deletion to this? And I'm sure that you all agree that the first thing that we want from our AI systems is to be accurate and exhibit low error rate. But beyond that, we want it to be secure or resilient to the different vulnerabilities and adversarial attacks. We want them to be robust to the different data and environment and condition not seen at the time of the training. We want them to be reliable and safe. We want to make sure that the bias is managed and mitigated. We want the AI system to be explainable and interpretable, and there are actually some legal framework that requires it. For example, AI is being used for certain applications. It should be able to explain the decisions or outcome that it came to, and of course, privacy preserving, that the data data used for the training is safe and preserved, and individuals' data is not at risk. So what have we done so far? So our foundational research at NEST is trying to, again, come up with these dimensions of the risk, the building blocks for trustworthiness, development of the terminology and taxonomy for them, and then map them to the different stages of the life cycle of the AI, to know the touch points of, for example, bias in AI life cycle, or adversarial machine learning, so on and so forth. We have built a research program around bias, explainability, and security. And robustness and accuracy, a lot of the work that we had done before can be applied here, and we are trying to understand privacy-preserving machine learning, and then safety and reliability. So I'm going to very quickly talk about some of the work that we had done. On the secure AI, we again started with terminology and taxonomy for adversarial machine learning. And then, as you know, our documents are always out for public comment. We do everything in close collaboration of the community and stakeholders. And after the document on terminology and taxonomy for adversarial machine learning, we moved on with developing a test bed for assessing the vulnerability of the AI. But what you see here is the architecture of that test bed, and the link on the bottom give you access to the source code. While we start developing this for assessing the vulnerability of the AI, we believe that the architecture and the code is modular and flexible enough to be used for evaluations of other aspects of the trustworthiness. We put out a document on 4 principles of explainable AI and followed that with for the public comment, and then a workshop in December 2020 to discuss the discussions about explainable AI. And then in early 2021, we put a document out on psychological foundations of explainable and interpretable AI to talk about the difference between explainable AI and interpretable AI. And revision of the 4 principles of the AI, explainable AI, should come out in the few months based on the input and the comments that we received from the community. We have a document out on bias in AR for public comment. Public comment is actually accepted until September 10th, and this document, a proposal for identifying and managing bias in AI, talks about bias at different stages of the AI life cycle and different biases for different stages of the life cycle. And we always get this question that, okay, how these documents that you're producing relate to development of the AI risk management framework, and the answer is that go back to the pyramid earlier slide that I talked about. These are trying to bring the community on the shared understanding of each of these aspects of the trustworthiness, and they all hopefully will fit into development of the AI risk management framework. We had a workshop back in June on trying to understand what evaluation of AI entails, discussions about the data, discussions about role of the human in measurement of the AI, discussions about how to test AI systems, how to understand when they fail, how they fail, and make sure that they fail safe. The recording of the workshop is at the link that it's on the bottom of the slide, and a report of the summarizing the discussions of the workshop, but also coming up with the next step is under development. One of the hats that I wear is the USGAI standard coordinator. That was a role that we recommended in the plan that we released on August 2019 on US leadership in AI, a plan for federal engagement in developing technical standards and related tools. As part of that, my job is to do the outreach to connect all known federal efforts relating to AI standard development, and with the goal of having a focus on positive participations and contributions to standard development efforts in AI, and leverage and learn from successes of other participants. What we do is that we facilitate ongoing discussions between US private sector and federal agencies to strengthen public-private sector coordination, and again, the goal is to have meaningful and strong participation and contribution to development of AI standards. So to summarize what we do, our AI program has these components. I talked about conducting foundational research to advance trustworthy AI technologies, that we start by trying to unpack the concept of trust and trustworthiness. And I will just say it here that I spend a lot of time talking about the concept of trustworthiness and building trustworthy systems, but just building trustworthy system doesn't automatically mean that you will have humans' confidence and trust in the system. So another important part of this trust equation is to build systems that are trustworthy, but also get the users and the people that are going to interact with the system trust and have confidence. And there are different roles for the users, from somebody that uses it to somebody that needs to procure it to policymakers. So bringing the human centered design for the AI is also an important aspect. And as I mentioned, NIST has a very broad portfolio of research, and our researchers across NIST are using AI for scientific discovery across many different domains that NIST is working, from biotechnology to robotics to information, quantum information, etc. Advancing measurement science, establishing benchmarks, developing metrics to evaluate AI technologies is extremely important, and something really in our core mission. We have done many evaluations in the past decade or two that are in their core are evaluations of AI systems. Examples of that are evaluations of the biometrics, now fingerprint recognition systems and face recognition system, FRVT, many of you may know it, or TREC that evaluates information retrieval systems. As I said, we did a workshop, and we're trying to build a more formal program around testing AI and testbeds for AI. We participate and lead the development of the standard technical AI standards to advance AI innovations, and we contribute NIST technical expertise to discussions around policies. And of course, bolstering expertise and having the right expertise, both in terms of our scientists, but also computation lab to be able to carry out our AI programs or activities that we do at NIST. With that, I'll thank you for your time and attention. I'll be at the speaker lounge to answer any questions you may have, and I look forward to see many of you there. Thank you very much.